Hello everyone. In this video, I'm going to talk about the blockchain in detail. So before starting, I would like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in data lake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are purpose of blockchain, what makes blockchain secured, some advantages of blockchain, and a few applications of blockchain. So let us start with purpose of blockchain. So the main purpose behind the introduction of blockchain is to eliminate two big problems we face in the traditional transaction system. So what are those two big problems? So those two big problems are, the first one is the double spending problem, and the second one is the need of central trusted third party. So to eliminate these two problems, blockchain was introduced. So let us first see what the double spending is and then go to how blockchain solves this problem. So this double spending is a flaw in the digital cash scheme in which the same token can be spent more than once. So this problem is unique to digital currencies as they can be replicated easily because you can think digital currencies as some digital file. So I'll give a simple example. I hope that clears whatever I said just now. So here a person A has a digital file locally saved in his computer. He can make as many copies as he wants, but this should not happen with digital currencies. Because if the digital currency is replicated, it totally loses its worth. So here you can see this person A has a digital currency saved. So you can think of it as a digital file. So this person A simply replicates this and sends the same token to both person A and B. So this is basically what the double spending problem is. So next let us see how does blockchain solves this double spending problem. So blockchain solves the double spending problem by utilizing proof of work, where the transactions are independently validated by miners in order to be added to the blockchain. So these miners receive a certain amount of Bitcoins as reward for their hard work in validating transactions and mining blocks. So this is how blockchain solves the double spending problem. So next let us see what is the next problem, which is the need of central trusted third party. So a network with a central trusted third party looks like this. So here we have a central repository or authority to which all the nodes are connected. So now if we consider this example, that is person A is trying to send $10 to person B. So he has to send it through the bank. So here the bank acts as the third party, trusted third party. The bank makes two entries, that is one debit and one credit. So here we must have this bank in order for this transaction to happen. So this is basically what a need of central trusted third party is. So next let us see a few shortcomings of having a central trusted third party. So the first one is single point of failure. So these central trusted third parties become a single point of failure because of mismanagement, greed, and if the people working there gets involved in some illegal activities. The next one is expensive. So these third parties are commercial entities and they charge for the services. So the amount they charge sometimes become too expensive for some people to afford. And these third parties also have the power to suspend customer accounts, and they can also deny access to our assets. So these are some of the shortcomings of having a central trusted third party. Next, let us see how does blockchain overcome the need of central trusted third party. So this is what the blockchain network looks like. Here every node in the network is connected to every other node. So blockchain is a distributed ledger which is completely open to anyone. So by completely open to anyone, I am trying to say that any computer can become a node and take part in this network. and take part in all the transaction validation processes and transaction making processes. So they have a peer-to-peer connections, as a result of which they do not have to depend on third parties. So this overcomes the drawbacks that having a central trusted third party involves. So this is how blockchain overcomes the need of central trusted third party. Next, let us see what makes blockchain secured. So let us consider this is the current state of the blockchain, in which there are just 3 blocks here. So this being the first ever block created, which is also known as the Genesis block. And this is the hash of the first block, and the previous hash will be 0.2000 since this is the first block. Similarly, for this block 2, this is the hash of the current block, and the previous hash will point to this. Similarly, for the third block, this is the hash of the current block, and the previous hash points to this. So if anyone tries to change any data in any block of the blockchain, it will, for example, this block 2 gets tampered with. So initially the hash was 6BQ1. Now let us consider anything inside this block is changed. So firstly, it will change the hash of the current blocks. So after it is tampered with, the hash of this will be changed to something else. Then the previous pointer of next block will no longer point to this. So this and this do not match. So this will no longer point to this. Hence, the chain will be broken. So now the attacker will need to rehash all the blocks starting from the tempered block to the last block or the current block being created. So here it looks quite easy because there are just 3 blocks, but in reality there will be thousands and lakhs of blocks. So it will be very difficult for the attacker to rehash all the blocks starting from the tempered one to the last block. Now let us consider that the attacker succeeds in rehashing all the blocks starting from the tempered block to the last block of the chain. Further, there is something called proof of work, which makes it even more difficult. So this is basically what happens when anything inside a block is changed. So next, let us see a scenario in which I'll show you what happens when anything inside a block is changed. So here I'm considering there are 3 nodes, that is node 1, node 2, node 3, and every node has a blockchain consisting of 3 blocks, block 1, block 2, block 3. So every node will have the same copy of this ledger or this blockchain. So the first block has 2 transactions, that is the first one is $10 from A to B and the second one is $20 from C to B. So it will have the previous hash as 0 since this is this first block or a Genesis block, and the current hash is, I have written it as 1A. So and the second block has just 1 transaction, that is $2 from A to C, and it has the previous hash that will point to this. So it is 1A and the current hash is 2A. And the third block also has just 1 transaction, that is $1 from B to A. So the previous hash will point to this, that is 2A, and the current hash is 3A. Similarly for the other nodes, since they have the same copy of ledger, right? Next, let us consider that this block gets tampered with. So here initially for this block 2, you concentrate on this block 2. So initially it had the transaction $2 from A to C. Now it is changed to $3 from A to C. So consequently, the current hash will be changed. Previous hash will remain the same, but the hash of this block will change. So I've just written it invalid. Hence the chain breaks because the previous hash, this one and this one, did not match. Hence the chain breaks. So now, these blocks starting from this block to the last block needs to be rehashed again by the attacker. Next, for example, the attacker succeeds in rehashing all the blocks starting from the tempered one to the last one. So he rehashed this block 2, and got the current hash as 2B. And block 3 he rehashed again and got the previous hash as 2B, which matches perfectly. And the current hash is 3B. So now there is something called consensus, and proof of work is one of the consensus algorithms by which all these nodes agree upon a single copy of ledger. So when this consensus algorithm is applied, these two nodes will find that node 1 has a different copy of ledger. So block 2 is changed. Your block 2 has a transaction of a $2 from A to C, and their hash and the previous hash is different from this. So these two nodes will find that node 1 has a different copy of ledger than theirs. So what these nodes will do is that they will simply discard this ledger of transaction and transaction on their own copy of ledger. So even if the attacker succeeds in rehashing the entire blockchain of a single node, but still it is not possible to corrupt the blockchain because this proof of work makes it difficult to do that, which is next to impossible to change anything in the blockchain. Thus we saw that. So this is what happens when an attacker, even if he succeeds to rehash the entire blockchain, even then it is next to impossible to change anything in the blockchain. So next let us see a few advantages of blockchain. So the first advantage is transparency. So blockchain is a type of distributed ledger where all the participants share the same documentation. So by documentation I mean the same copy of ledger. So the already present ledger can only be updated through consensus, where majority of the participants should agree to it. Thus data in the blockchain is more accurate, consistent and transparent. So transparency is one of the advantages of blockchain. The next one is reduced transaction cost. So since we have seen that blockchain allows peer-to-peer connections, hence there is no need of central trusted third party. Since there is no third party involved, hence reduced cost. The next advantage is decentralization. So blockchain does not depend on a central server to save the data. Hence, there is no single point of failure. So decentralization is one of the advantages of blockchain. The fourth one is user-controlled networks. So blockchain does not depend on third party for its transactions to happen. Instead, every user can choose to be a part of the network and take part in the transaction validation and making transactions. So this is what is meant by user-controlled network. So the last advantage that I have mentioned on this slide is faster transaction settlements. So transactions through blockchain are faster as it is working 24/7 unlike other financial institutions. So transparency, reduced transaction costs, decentralization, user control networks, faster transaction settlements are some of the advantages of blockchain. Next, let us see a few applications or use cases of blockchain. So the first application of blockchain is cryptocurrency. So I'm sure you all know that blockchain was initially developed for the cryptocurrency Bitcoin, since it allows its participants to keep track of the transaction of the digital currency without a single central authority. Hence, blockchain could overcome the problem of double spending and the need of central trusted third party. The next application is digital identity. So blockchain technology stores data in a decentralized, trusted and immutable manner and can also ensure that a user's single digital identity is stored in a secure and incorruptible manner. So this single digital identity can always be made up to date with the latest user information. Since we know that in the blockchain, once the data is inserted, it cannot be changed. But we can always insert or enter new data. So the next application is smart contracts. So this smart contract is nothing but a tiny computer program which is stored inside the blockchain. So it is a piece of software that stores rules for negotiating the terms of an agreement. It automatically verifies fulfillment and then executes on the agreed terms. So the smart contracts remove reliance on a third party when establishing business relations. Thus, the parties making an agreement can transact directly with each other. So the smart contracts are designed and implemented with blockchains, and therefore they inherit some of the properties of blockchains, which is they are immutable and distributed. So this is basically what the smart contracts are. The next application is digital voting. So this blockchain voting is an online voting platform that allows a secure, hassle-free, reliable and quick method for the purpose of voting for an election. So the use of this technology from a voter's point of view is very simple. So anyone with a phone and internet access will easily be able to understand the specifications of the platform. So when we use this digital voting or the blockchain voting platform, so then the citizens who are voting do not have to wait in long lines and do not have to travel far for the sole purpose of voting. So this quick and hassle-free method of voting will engage more and more people to participate in the voting process and be a part of a more democratic world. The next one is the real estate. So for real estate, blockchain has the potential to change the way they do business. So the smart contracts that are being developed will enable real estate contracts, property records to be completed and money is distributed without title companies or attorneys. So these contracts are often compared to a vending machine concept. You just deposit your money and the machine spits out a product with no human intervention. So the last application that I have mentioned on the slide is the supply chain management. So for supply chain management, the blockchain technology offers the benefits of traceability and cost effectiveness. So this blockchain can be used to track the movement of goods, their origin, quantity, and so forth. This brings about a new level of transparency to business ecosystems by simplifying processes such as ownership transfer, production process assurance, and payments. So these are a few applications or use cases of blockchain. Although there are many more, but I have just explained a few of them. So let us have a quick recap of the topics we covered in this video. So in the beginning, we saw what is the purpose of blockchain, that is why at the first place blockchain was developed. Then we saw what is the double spending problem, which is one of the reasons why blockchain was developed. Then how this blockchain solves this problem. Then we saw the need of central trusted third party, which is the second problem for which the blockchain was developed. Then we saw why this central trusted third party was a problem. Then we saw how this blockchain overcome this need of central trusted third party. And then we saw what makes blockchain secure and why cannot we tamper with anything inside a blockchain. Then we saw a scenario where we tried to change a block or any information inside a block, and how even after rehashing the entire blockchain, even then we cannot change anything in the blockchain. And then we saw a few advantages of blockchain, and at last we saw a few applications of blockchain. Thank you for watching this video. In the next video, I'll be talking about the different types of blockchain which will include public blockchain, consortium blockchain, private blockchain, difference among private, public and consortium blockchain, why do we need different types of blockchain, and some of the industry giants that are currently using blockchain. Kindly provide a valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. Thank you very much. Let's keep learning.